just imagine that we were still in the jungles of Africa. Okay, so we sit on a bunch of trees, and Elon Musk says, "Look, there are some other trees far away that we can go to." And then you realize those trees do not have actually any fruits on them. Mars is a worse place than where we are. That's not such a visionary idea to go to that other group of trees.
Our neighbor's choice.
All right, we're going to have a fun conversation. This is a returning guest for our shows, our Science and You segment that we do. I'm your host, David Gornoski. And the last time we spoke to our special guest that we have today, it was on radio several years ago. I think 2018 was the time, somewhere around there. And we were talking about a mysterious object that had come into our solar system. I believe that was the topic of interest that we had him on. And it was quite a great radio show. And now we join together once again, whether you're listening on audio, podcast, or video platforms, we're glad to have you. Of course, with our Science and You segment, I'm joined by my co-host and physicist, Dr. Weiping Yu. How you doing, sir?
I'm doing great. Thank you for having me, and so happy to have a discussion.
Yeah, and our guest today
distinguished guest
is Dr. Avi Loeb. He's the Frank Baird Professor of Science at Harvard University. He's a best-selling author with books that have charted the New York Times, Wall Street Journal, Publisher Weekly. He received his PhD in physics from the Hebrew University of Jerusalem in Israel at age 24. He led the first international project supported by the Strategic Defense Initiative. That would be known as Star Wars, I think. Maybe he can tell us a little bit about that. And he's written 9 books, including most recently Extraterrestrial and Interstellar. Dr. Avi Loeb, how you doing, sir?
Doing great. It's a great pleasure to join you. And you look younger than I remember you.
I guess I'm reverse aging. I don't know what happened. Well, yeah, it's great to have you back. And, I want to let you guys kind of dive in together and talk, shop as physicists, if you want, but let's set the table a little bit about your latest book, Interstellar. That's a quite a topic. A lot of people want to go to the stars. A lot of people think the stars are coming here, right? We've had folks come on. We don't really get into the UFO topic too much. It's not really we get more into the science, but that's something that you've become well known for, right? Is talking about these possibilities and objects.
Well, I think going interstellar is a sign of intelligence because right now we are focused in our attention on what happens on the surface of the rock that we were born on, the Earth. It's just a tiny rock, 3/1000 of the mass of the sun left over from the debris disk that existed early on after the sun completed its formation process. And, we think that this is the only thing that matters. So not only we're focusing on the solar system, we're focusing on Earth, which is really crazy given the fact that there is so much real estate out there that we ignore. And we invest $2.4 trillion every year in military budgets. Just engaging in conflicts on territorial disputes on this earth, that just think about it. And a much more intelligent thing to do is for us all to collaborate in exploring space, even beyond the solar system, because there is so much out there that we don't know about. And also this way we would protect at least a portion of humanity from all the catastrophes that are awaiting us. At the very least, even if we do everything right and protect the Earth from asteroids impacting it, protect it from climate change, protect it from nuclear wars, we would not be able to escape the fact that the sun will get brighter and in 1 billion years will dry up all the liquid water on the surface of Earth. And then in 7.6 billion years, the Earth will be engulfed most likely by the envelope of the sun, and we would be dragged I mean, the Earth would be dragged to the core of the sun and become part of the white dwarf, the compact remnant that is left behind there. So my point is, anything we cherish, anything we care about, all of our ambitions will be buried in this white dwarf. It's sort of the corpse of the sun, the leftover. 60% of the mass of the sun will condense to a cold object that is the size of the Earth, called the white dwarf. We see those white dwarfs, there are billions of them in the Milky Way galaxy, sort of like looking at a cemetery, where you see all these dead bodies of stars like the sun that existed before the sun. And this is our fate. Now, one way for us to be remembered, by the way, if we die on this Earth, nobody would care, like there wouldn't be a funeral in the Milky Way galaxy. Nobody cares. The only way that we can be remembered in the history books of the Milky Way in the long term is if we go interstellar, leaving the solar system, go on a spacecraft, a space platform that can carry us for many thousands of years through space. And by the way, if we were to invest maybe, let's say, $1 trillion a year, that's a fraction of the military budgets. If we were to invest that in space exploration every year, I think within this century, we can build a space platform that can carry humans under very comfortable conditions, because such a project will attract the best architects, the best engineers, the best scientists. And instead, what are we doing? We're saying, maybe we'll go to the moon, maybe we go to Mars. But going to Mars is really a bad idea because it's a worse place than Earth. Why should we go to a worse place? Why should we aim low? Let's aim high, build a space platform that can accommodate humans in a comfortable environment with nuclear reactors providing energy. We don't need to be close to the sun. And this should be the ambitions of humanity. And I'm not naive. I don't think people will just decide to do that, politicians or... I think it will happen if we discover that another civilization did that already. And if we find a technological object visiting the inner solar system from interstellar space. And so to find out, we are now starting to discover interstellar objects, and I'm just recommending to check if any of them is technological, because it will change the future of humanity.
Very interesting. I think that's something that a lot of people are talking about. Elon Musk is talking about that. Of course, you mentioned Mars, but you think we got to go bigger than that, huh?
Yeah, I think Elon Musk is just imagine that we were still in the jungles of Africa. Okay, so we sit on a bunch of trees, and Elon Musk says, look, there are some other trees far away that we can go to. And then you realize those trees do not have actually any fruits on them. Mars is a worse place than where we are. That's not such a visionary idea to go to that other group of trees, a visionary idea is to leave the continent, go somewhere else. So we really need to be more ambitious. And I'm saying it's not completely crazy if we were to change our priorities. Just think about, instead of focusing on preventing others from killing us or killing other people, instead of doing that, we just say, let's work together and build something for space exploration. That's the only thing that we need, change of priorities. And with $1 trillion, just think about $1 trillion a year, that's like a budget that is bigger by a factor of, 50 than the budget of NASA. Every year, with such a budget, 50 NASA, over a period of 50 years, we should do miracles if we dedicate it just for that.
I definitely support you. Okay. And I know you always think big and think deeper. Okay. So people already think Elon Musk is bold enough. Okay. Colonize Mars. And you still think that's not ambitious enough.
No,
Well,
it's not. I think because Mars, if we were to live on Mars and we would say, look, there is this planet called Earth, let's go there because it has an atmosphere, it has a lot of good things, then I would be very much in favor. But going to a worse place, that's not a great thing to do for people. I mean, you can send instruments, that's fine, but you can't survive on the surface of Mars for more than a few years because your body is bombarded by cosmic rays. You have to go underground. It's really complicated. And I just don't think it's good to send people to such a bad location. Like I think we should build a space platform that can accommodate people and give them everything they need.
If if you be a NASA administrator for now, so what kind of project you're
Oh,
gonna
okay.
promote NASA to do?
Well, yeah. So there are different types of projects. One is scientific, just learning more about the universe. And in the context of scientific projects, I think it's very important since we are now discovering interstellar objects. There is the Rubin Observatory in Chile with a camera with 3.2 gigapixels that is surveying the southern sky every 4 days and finding new interstellar objects. It will find every few months. So the one thing we're missing is, we need to bring a camera very close to an interstellar object to figure out what it is. That would be really nice if we had an interceptor. And I believe that would be a great mission to have. And we can also plan, for example, to land on an interstellar object, because this object, every interstellar object, spent billions of years traveling through space from its parent system. And it will take us billions of years to go there and visit those systems. But now we have this material close to us. And if we were to land on an interstellar object and bring materials back to Earth, it's just like what we did with the asteroid Bennu, the OSIRIS-REx mission that NASA funded, landed on the asteroid Bennu and brought 120 grams of material. And we found that most of the amino acids that are the building blocks of life exist on this rock, this asteroid that had no life on it. And that, of course, tells us that the building blocks of life are everywhere. Because if you find it on a rock, just a random rock, in the solar system, then it should be everywhere. So that was very successful. The OSIRIS-REx mission that brought 120 grams from the asteroid Bennu. And that was analyzed just over the past year. So that's a great success. But I'm suggesting to do the same thing about an interstellar object, because think about it, it's a completely different way to find the building blocks of, whether the building blocks of life exist in material that came from another star. Right now, the astronomy community is thinking about remotely observing. This is called the Habitable World Observatory. It's one of the future missions that NASA will be engaged in, where the idea would be to look at the chemical composition of atmospheres of other planets far away to see if they have perhaps the signatures of life, like oxygen, methane, things like that. But that's called remote observing. It will cost more than $10 billion to NASA, and it will take 2 decades to develop. I'm saying there is an alternative method that nobody talks about, nobody. And that is just like the OSIRIS-REx mission, except doing it on an interstellar object. Because even if it's a rock or an iceberg, you land on it, you bring some material to Earth, then you can tell if the building blocks of life exist near another star, which is very far away. There is no way for us to visit another star in any foreseeable future. So this is an opportunity that, of course, I am highlighting, but nobody else speaks about it. And I think it would be amazing to do that, kind of to think about a concept for such a mission. So one mission could be just sending a camera close to an interstellar object so we can see how it looks. But a more ambitious mission would be to land on it and deliver some material from it to Earth, because that will be the first time that we have recovered materials from an object that originated near another star. So that, in terms of the science, that's an original thing that I'm suggesting. But of course, NASA has other plans for other things, including the Habitable World Observatory, which was priority number 1 in the decadal survey. And NASA has other plans, of course. I very much like the idea of visiting, obviously, Titan, which is the only other object in the solar system. This is a Dragonfly mission that NASA will have in a few years, to visit Titan. That is the only other object in the solar system. It's a moon of Saturn and has liquids on its surface. The Earth has liquid water, Titan has liquid methane and ethane. And we want to know if life is possible in other liquids, not just in water. So that would be amazing. Then there is the possibility of studying Europa and with the Europa Clipper and other missions, and studying also Enceladus potentially for any markers of life in the geysers, in those plumes of gas that come out of the cracks in the ice on the surface of these moons, Enceladus and Europa. I think that would be amazing. So all of these examples that I'm giving are in the context of the search for life, because I think that would, first of all, the public cares a lot about this. And it's about time that we discover life beyond Earth. That's the next big discovery. And if NASA does it, it will get a lot of credit for that. We've seen a lot of black holes. We've seen a lot of galaxies. Okay, so we see them farther away. We see more of them. That's what the Webb telescope is doing. It's good science. It's informative. It's on a subject that I originally was helping NASA develop the Webb telescope concept because of the first stars, the first galaxies, a subject that I pioneered. But it's more of the, it's not qualitatively new. And the biggest frontier that will be qualitative new and will inspire the public about science is to find life beyond Earth. And so all of these items that I just mentioned could potentially do that. And that would be amazing if we do it in the coming decade. But this is science. Then there are other aspects of NASA, and one of them is, the space race to the moon. There is obviously competition with China, and there is this ambition to put a nuclear reactor on the moon as a new technology that goes to space. Actually, what I think would be very exciting, and nobody talks about it. So once again, for me, it comes naturally to suggest these ideas. I'm just surprised that nobody talks about it. We are developing artificial intelligence on Earth, right? So it's a new frontier, an amazing frontier. And the question is, can we deploy artificial intelligence in space? And so that, I think, would be an amazing thing for NASA to pursue, using equipment that has its own brain, like artificial intelligence, so that it can make decisions. When we send such equipment to the moon, Mars, or beyond, it will not need to get guidance from the Jet Propulsion Lab engineers, because it will have its own brain, can decide what to do in real time, correct things. And so bringing artificial intelligence to space, I think, would be amazing. Nobody talks, I haven't heard it. It was not that. So I'm just giving you two things that nobody talks about that to me sound straightforward. Artificial intelligence to space, a new frontier that NASA can pioneer. And the second new frontier is bringing materials from interstellar object back to Earth.
It's all great idea, NASA right now, major focus is as human space travel,
I know.
space program, right? So human biological life, that, right? Biological life have a limited, have to live on the food, water, have a limited supply.
Exactly.
So we need to use AI and use robots, right? For
Exactly.
interstellar traveling.
Yeah, for interstellar, it's mandatory because it takes even light tens of thousands of years to cross the Milky Way galaxy. So you can't allow your probe to wait for guidance across large distances. So the point is that whenever we go very far, we have no choice. We must give AI brain to our equipment so that it can make its own decisions. And so we haven't yet used AI in space, and I'm saying nobody talks about it, but this is something that should be pioneered.
I want to ask you what is the mechanism of getting around to this interstellar travel, right? So we have the traditional rocket technology that we're familiar with. Then we have, these, and I want to ask you, you've been known to talk about these strange interstellar objects. What's it called? Oumuamua? How do you say?
Oumuamua was the first one.
Yeah. What is that supposed to mean again?
It means a scout in the Hawaiian language. This object was discovered by telescope in Hawaii back in 2017. Yeah.
So what's the latest on that? What have they been able to
confirm?
The
thing is, we could see it only for a few months, because once it gets farther from the sun, it gets extremely faint. So we couldn't really observe it. The nice thing about the latest interstellar object, 3I Atlas, is that it came in the plane of the planets around the sun, the so-called ecliptic plane. So it spends a lot of time in a regime where it's observable because it came close to Mars, then close to the sun, and now it's heading to be close to Jupiter. And we have observatories on Earth and in space that can look at it. And for almost a year now, it will be by the time it gets to Jupiter on March 16th.
Wow.
So yeah, so we don't know much about Oumuamua. It was a surprise. It had some unusual properties. In terms of traveling through interstellar space, it depends on how patient you are, because if you're willing to wait 1 billion years for the trip to reach a destination on the other side of the Milky Way galaxy, let's say, then you can use the 1970s technologies. I mean, that's the amount of time it will take the Voyager spacecraft to move to the opposite side of the Milky Way galaxy relative to the sun. So if you're patient and you're willing to wait 1 billion years, no problem. And actually, most of the stars in the Milky Way galaxy are billions of years older than the sun. So if there was a civilization like ours next to them, they had plenty of time to reach us by now with the 1970s technologies of Voyager. So these are rockets, but a much more advanced, in principle, you can reach close to the speed of light. For example, with a light sail, if you're pushing a sail with light, it can reach the speed of light. But that's a technology that I was actually leading the advisory board for a project called Starshot that was intending to develop that technology of light sails. That's what gave me the idea that maybe Oumuamua is being pushed by reflecting sunlight, by the way. But we don't have it available at the moment.
What was the object that was lost at sea? I remember you in the news were talking about that. Tell us about that.
Well,
there's a lot of stuff to catch up on since we last talked to you.
Yeah, we can spend the full day. But yeah, so that was a meteor that was discovered back in 2014 by the US government satellites that monitor the Earth for ballistic missiles. You know, they look for the heat generated at the launch of ballistic missiles. We know that a year ago, there were a bunch of those launched by Iran, you know, and they were obviously, some of them were mitigated as they were launched, because these satellites are monitoring the Earth with a response time of a fraction of a second. They know exactly if there is a ballistic missile anywhere. Every now and then they see a fireball generated by the collision of an object like a rock with Earth. These are called meteors. When an object burns up as a result of its friction with air in the atmosphere, you end up with a fireball just like an atomic explosion, or it releases a huge amount of energy. And there is the equivalent of Hiroshima atomic explosion energy every year in the atmosphere, and from an object roughly a meter in size. We don't hear about it in the news because these explosions are so high in the atmosphere, they don't cause much damage on Earth, on the ground, you know, and most of them hit the ocean eventually. But anyway, so in 2014, there was a meteor, and NASA is recording those events that have nothing to do with national security. These are just objects that collide with Earth, and so they are cataloged by the Jet Propulsion Lab. And I realized that this catalog exists back in 2019, and went to it, and with my student Amir Siraj, we analyzed the data and found one meteor that was moving too fast to be bound by gravity to the sun. So definitely came from outside the solar system. And in fact, it was moving at 60 kilometers per second outside the solar system, just like 3I Atlas. We wrote a paper about it, and I decided to lead an expedition to the Pacific Ocean where we looked for the materials from this impact. I just wanted to figure out if it's a Voyager-like meteor or maybe a rock. I just wanted to find something from it. And we spent a couple of weeks at the Pacific Ocean, and collected materials, mainly droplets that are less than a millimeter in size. And then we analyzed them and found a fraction of those to have a chemical composition different from solar system materials. And all of this is documented by a Netflix filming crew that came with me on the ship. And you will be able to see a documentary in 2026, hopefully, on this expedition and what we found.
Very interesting. Dr. Yu, any questions?
Oh, sure. Professor, one of my passion is, anti-gravity propulsion. Okay. So since you are champion for interstellar exploration, right?
Yes.
So what kind of propulsion in your mind?
Yeah, so
accomplish this kind of traveling.
The best propulsion would be if we were able to create a negative mass, which let me explain. So in Einstein's theory or in nature, we find only positive masses. These are objects that attract gravitationally. But if you make the analogy with electromagnetism, you could imagine just like positive and negative charges. You can imagine positive, negative mass. And in principle, it's allowed. There is nothing in Einstein's general relativity to forbid it. But just imagine that you have a payload, that NASA has a payload that it wants to launch. And what you usually do is attach a huge fuel reservoir to the payload so that you burn up the fuel and you push it in a rocket. That's what you do. I'm saying you need no fuel at all. If I have a negative mass equal to the positive mass of the payload is positive mass, you attach a negative mass of equal magnitude, then this thing has altogether zero mass. So that means that it's like a balloon. It floats in gravity, and you just give it a slight nudge with your hand upward, and it will fly out of the Earth's gravity. You don't need a fuel. So if you have access to a negative mass, in principle, you can end up with propulsion without fuel. And just to give you the sense of that, if these two objects, if you consider the gravitational influence they have on each other, the positive mass attracts the negative mass gravitationally, and the negative mass repels the positive mass. So you end up with the two of them accelerating together indefinitely. They can accelerate up to the speed of light, no problem. And this idea came up, was proposed by Hermann Bondi back in 1952 or so. It was an physicist that calculated the space-time around the positive-negative mass pair, a dipole, gravitational dipole, and found a solution in Einstein's theory of gravity for such a pair. Now, the only problem is we don't know how to make a negative mass. If we could do that, then of course we can accelerate the payload up to the speed of light with no necessary fuel. So that's an example. Now, in principle, you can imagine more sophisticated methods, but to me, that is an illustration that in principle, if we know, for example, that the expansion of the universe is accelerating, so there is dark energy. If we can bottle it, if we can make an object that has repulsive gravity, just like the dark energy, that would be, of course, one way of fueling things without the fuel, just driving things gravitationally.
That's right. I was thinking about it. So I thought anti-gravity is pretty wild. So now you propose maximum mass. So I was thinking about how do you
make negative mass? Right? I should say I should disclose that I'm actually with a few collaborators. We are working on a paper trying to suggest a way of creating a negative mass. We haven't yet finalized all the details, but the hope is that we can somehow create configuration of electromagnetic field that would have a negative mass. We should see.
Okay, so based on the UFO phenomena, do you believe those are really? I know we do not doubt it that there's alien life, right? That's your passion, so we have no problem. But do you really believe there's alien really visited the Earth before?
Yeah, I think it's very possible. It's not, but I don't think it's a matter of belief. I think, well, first of all, we are not that attractive. We should realize that. When you ask, like Enrico Fermi asked, where is everybody? That's a very arrogant and presumptuous. What you tell people who don't find a partner is that you're not that attractive. You need to search for a partner. I think anyone that reads the news is not very happy with what humanity is doing most of the time. Like there is room for improvement, and I will not blame aliens for not getting in touch with us just because they think we are not that smart, because you just see what we are doing most of the time. It's not very impressive. But coming back to your question is, I think it makes much more sense to be practical and say, okay, if there are any visits, let's look for any evidence for that. That's the way that any scientific research is done. You look for evidence for, and I'm leading the Galileo project that has now built 3 observatories, one in Massachusetts, another one in Pennsylvania, and a third observatory in Nevada. And we are monitoring the sky all the time in infrared, optical light, and also radio and audio. And we will monitor a few million objects in the coming year. And we use machine learning software to figure out if any of them is an outlier, might be something that goes beyond the performance envelope of human-made technologies. And so that's the approach I take. I don't know who to believe. There are people telling stories about what the government may have, and I haven't seen any evidence for that. So I'm just saying on a practical level, since the intelligence agencies are saying that they cannot identify some objects in the sky sometimes, and I'm saying let's look at it scientifically, collect data, and figure out if there is anything unusual in the sky. And if we don't find anything that is extraterrestrial, then it will still be useful because the Pentagon can use it for national security. The sensors that we develop, the software that we develop can be used. And I'll be happy to give it to, if afterwards. But if we find anything that is beyond this Earth, then of course it will be a huge discovery for science.
Let's assuming they visited the Earth before, right?
Okay.
So what kind of propulsion system do you think they already mastered?
Oh, I don't know. So the way when you go on a blind date, my advice is to always listen to the other side, observe the other side, and not have a prejudice, not assume what the other side is. Because when you assume what the other side is, that's a recipe for the worst marriages ever made. Like people imagine the other side to be something, and then it takes them years to figure out that they were wrong. And so the best approach, if you want to find the right partner, is to observe the other side. So people ask me, what do you imagine? And I say, I'm just looking for something that I haven't seen before. Like it's not human made, it's not a natural, it's not a bird, it's not an airplane. And it's not Superman. It's something else that looks very different.
So what kind of a form of life do you think, interstellar, those objects
I
in
think,
your mind? So they are not a biological life, are they?
No. I think most likely it will be AI equipment. If it's functional, it will have its own brain, artificial intelligence. That's why I was suggesting that NASA started doing something about it. But another civilization that had more than 1 century of science and technology, like we did, they can develop probably spacecraft that have AI, very sophisticated AI, and that's what I expect to encounter if we ever see a functional devices.
Yes, one thing, before I come to this meeting today, I watched one of the video you interviewed 2 days ago. You mentioned about whenever you post a new broad, great, a big idea, you got a lot of pushback from your colleagues, right? From peers, which
Yeah.
I feel the same thing. Okay, I'm on your camp.
Right.
So tell me about what's your view on the gatekeeping or in science community in general?
Yeah. So first I should explain why does it happen. In my case, it happened because I get a lot of attention from the media, from the public. And
That's a good
I
thing,
get
right?
so much. Even like last month when I ordered the dishwasher, when I called the company, the guy on the other side said, "Is this Avi Loeb?" Before I even I said, I listened to you on all the podcasts, so I'm recognized by my voice. I spoke on the phone with this guy, so people know me, and there is a lot of attention. And the biggest force in academia is jealousy. So I noticed that before I got all this attention, there was no issue. Nobody was upset that I come up with ideas. Many people use them. It was greatly appreciated. But as soon as the public started paying attention to my narrative, then people got upset. And I interpret that as academic jealousy, that I get this recognition. And I don't care much about it because I'm not I'm not in the business of communicating science. I mean, there are science communicators that are not practicing science. People like Neil deGrasse Tyson or Brian Cox. They're just talking about what other people are doing. That's okay. You need commentators. That's good, and they publicize what happens. But they are not practitioners of science. They are not engaged on a day-by-day basis in writing papers. I just wrote 2 papers this week. 2 papers this week. So I'm doing the scientific work, and surprisingly, I speak in a way that a lot of people understand, so they follow me. Okay, so I get some attention, but I don't really care if people push back because I'm doing the scientific work. That's the way it should be done, And many of these people who push back and attack me personally and so forth, either they do not do science or they're frustrated by the fact that they didn't get academic positions. There is a guy that calls himself a professor, and he never held an academic professorship. And he put 2 YouTube videos trying to attack me. And he calls himself a professor, so he's already lying from the beginning. He's
Oh, I
lying about,
know who you are talking about.
So this guy who is lying about himself, pretending, and he is criticizing me, and I'm a real professor for 32 years at Harvard University. 32 years. I've been at Harvard University more than the president of Harvard by a factor of 2. I've been in academia. I've gotten tenure almost 20 years ago. No, actually more. Yeah, almost 20 years. So altogether, I've been in academia. I was chair of the astronomy department at Harvard for 9 years. I've had a lot of leadership positions. I'm doing research, okay? And then you have a guy that doesn't do research, he was not good enough to get a position in academia. And he's creating YouTube videos attacking me to get, 500,000 views and lying, basically, saying things that are incorrect. So, we live in a time that where misinformation can get a lot of attention, and it was all cultivated by social media. And so this is unfortunate, of course. And we have to swim in this water, because that's the environment we live in. Within academia, for example, people that know me, I don't get pushback from them. We can have a conversation, they can disagree, and I try to make my arguments. That's a fair game. Most of them that know me, didn't change the way they converse with me, because they know me. I've been arguing with the same set of new ideas in other frontiers of science before. There is nothing changed. The only thing that changed is that now I have much more visibility, and that's triggering a whole group of zealots who are mediocre scientists to attack me.
Wow.
Yes. Okay, David, you go ahead.
Oh, you go ahead. You had something you want to say. I wanted to.
Oh, okay. So I'm feels so interesting because the professor mentioned about the online professor. I don't want to say he has the same name as my partner. Okay, the first name.
Right.
Yeah. I don't think you should care. My friend, Ashton.
By the way, there were some anti-Semitic and comments in his YouTube video. Some of the personal attacks are really of the lowest level. And I don't want to mud wrestle with people because it gets everyone dirty. I don't want to engage with those people because they are they have nothing better to do than get attention from attacking me.
And I have to say, I have to
they're
say
like
that
parasites.
you see that kind of mudslinging. I have to say, as Dr. Yu's friend, he's gone on, other shows that are bigger than mine, even though we're still holding down the fort here, but he's gone on Patrick Bet David and
I've been
Redacted.
there. I've been
Yeah.
there.
And
Yeah.
every time, when he gets presented to a mass audience with millions of comments and stuff, you get people saying ethnic slurs or making fun of his name. So it's
Right.
just people treat their view of science and the world almost like it's a religion, like it's
No,
something that
no, but there is
challenges their
another.
identity.
There is another effect which is similar when you look at at a whale. Around the whale, there are lots of small fish that are benefiting from the existence of the whale, or all kinds of small animals. These are parasites, okay? And whenever you get recognition, either as a rock singer or as a movie actor or actress, if you are very successful, you immediately get haters. There is no escape from that. And the way I see that is as online parasites. These are people that get to the limelight by saying bad things about people who get some public recognition.
Yeah, I wanted to express my view about the online professor. For me, I don't think you should care, because for me, I think if you made on his video like over hour-long video, multiple videos or for months, right? I mean, that means you are famous now. So they only pick the hardest topic, right? So that's why they can generate millions of viewers. I know.
Oh, yeah.
Because
No, a month ago, there was a number of people that decided to create a YouTube channel with my name, Dr. Avi Loeb, on it. And they created AI generated videos of me speaking. And they were so wide. I mean, they immediately got 1 million views just because the video speaks in my voice. The only difference is the clock behind me that you see on my side here. It was not moving in the AI fake videos. But other than that, there was even a reporter that used one of the videos to report about what I say. And I didn't say that. So then I contacted YouTube and I said, look, NBC News is about to interview me tonight about the fake videos, and there was already an article in Futurism, and I said this story will get bigger unless you remove this channel, and they said, why are you worried about it? And I said, look, this is stealing my identity because I don't approve of the content. It's just like a stealing identity of a person. And so they removed that channel, but a week later there were tens of other videos everywhere scattered around it. So we are entering a new reality now, which is, it's not just those bloggers or YouTube creators who are providing misinformation, like we were talking about before, that are not qualified, that are not scientists, and yet they comment about science. There are also AI generated videos or content that the public will have a hard time. And I always say, when people ask me, is this video real or not? I say, look, right now, you should believe everything that you see with me in it, that is part of a podcast like the one we have now, because it's much more difficult to generate a fake podcast as of now.
That's right.
And or television interview, or what I write on medium.com. I put essays every day under AVI-LOEB, that's my first and last name, .medium.com, and if whatever you see there is my content, it's authentic. But because some people were asking me, oh, on this video on YouTube you said different things, and I say, no, that's not me.
Fortunately, now people can identify it's a real live interview or it's a video game. Technology is not perfect yet, so
but it might in the future.
In the future will be.
Now the problem is really, this is the worst thing that can happen to science, because science is all about credible information. Okay, and as soon as you put scientists in fake videos and content that cannot be distinguished from real content, you will muddy the water. It's like water that we are drinking from, and if someone muddies the water or throws poison into the water, then that's it. You can't use it anymore. And so if into all the communication outlets, we will start getting content from AI generated, and it doesn't need to be a video. It could be, for example, when students or researchers start to use AI to write scientific papers, there would be a lot of mistakes associated with the AI making mistakes or fake data that the AI invents. Once you muddy the waters of science with AI, everyone talks about the great benefits that AI will bring to science. I see also the risk from misinformation, from fake data. And I wouldn't be surprised if already 10% of the publications in science are written by AI, not recognized, and have false content.
That's a danger. That's one thing. I'm a NASA employee, right? So NASA try to prevent you provide any data. It's not NASA internally generated.
Right.
Or contracted with Boeing, SpaceX, or something, direct hands-on work, because AI can tell you anything you wanted to hear.
Yeah, that's the problem. And people sometimes want to believe, it's not just the AI that is lying, it's the fact that the lies are better than the reality. So people want to believe those lies. If the AI says good things about you, you get attached to it. So a lot of people will have AI companions that are much better as far as they are concerned from human companions because they never get into a fight. The AI always says good things. I'm really worried about AI capturing the human mind in two ways. One is I'm worried that students that use AI all the time, they are getting dumber. They're getting dumber. They're not using their brain to think. And they use the AI to think for them.
It's like if you take photographs with your smartphone all the time, you'll find your memory slips a little more, because your body learns, okay, I've got a little extra hard drive to, capture all these memories and moments, so it gets a little slack on holding those memories.
Well,
I don't know if there's anything to it, but I've noticed it. So
yeah, and I make the analogy with sports. If you don't use your muscles, you lose them, right? So the point is that you need to use your brain, your critical thinking. If you rely on the AI to tell you the answer to everything, you are losing your brain cognitive power. And people are not aware of that. So one thing is that people will get dumber. That's what I'm worried about. And I already noticed that, by the way. I noticed students that use a lot of AI are not as smart. I noticed that.
Are they all writing their essays for you in AI now, or what are you?
Well, that's a big issue, how to evaluate a student, because the written exam is not really a good way. What you want is an in-person exam where you can on the spot ask questions and see how the student responds to that. Because if you let them go home or do the homework, you can't really tell if it's the AI or them. Well, it doesn't
you have
matter
to interrogate them a little bit. That's the last place is the in-person interrogation to see if they really, if you need to award the doctorate to Grok or to, them, right?
Yeah, and the other thing is, of course, the teaching itself is, in the past it was providing information. Now they can get the information from AI. So it's more, I think the teaching will be more about how to think, than about information. But
discernment. Having discernment and wisdom is something that's totally underrated in sometimes,
Yeah. I mean, it doesn't matter so much at Harvard because all the students get an A anyway.
Yeah.
But
are they still doing that? I thought they rolled that back.
Well, they're trying, but it's really a big. They want most recently the idea was to invent an A plus, so that you can distinguish the really good students. But the point is that aside from people getting dumber, there is the issue that AI can capture the human mind in ways that would be much more extreme than social media. So I'm worried that it will create, polarization in society. People will. I mean, already we see a lot of weapons being used. Like people are shooting, and they're shooting because they are in a bubble, in some social media bubble or in an AI-dominated culture that could be quite dangerous for society. So I'm worried about, you don't need robots to destroy the physical reality that we live in. You just need to convince humans that they need to do that. That's all. And the AI can do that. And I'm worried about how to protect us from such a thing. And So all in all, it's not clear to me whether the good is more than the bad, but obviously there is no way for us to retreat from AI. So we need to do it, to develop it with open eyes and start putting some guardrails that would maintain the integrity of society and will keep people still thinking, not doing everything based on what the AI tells them.
What do you think about, talking about intelligence and all this works? There's a lot of people still wanting to know what the theory of everything could be, because is that, for example, Dr. Eric Weinstein talks about this notion of, we need to get, he's a mathematician. He's teaching us on his lectures that we need to find a new way to get way out of our galaxies and travel way beyond anything, kind of similar to what you've been saying. So do we need a new theory of everything to get to that point?
Well, he's a good friend of mine. I think it's very naive to think about the theory that you will have a theory of everything, because even if you had the fundamental equations, one thing we know is that, and in fact, that's what NASA does most of the time. NASA has the fundamental equations for what it needs to build, but just solving these equations for the relevant circumstances and is not easy, so part of the complexity of nature is not having the fundamental equations. It's about being able to understand complex systems, and this is something we are starting to do right now. In understanding, for example, biological systems and so forth. So understanding the theory of everything will not really, if we had developed a theory of quantum gravity, it would not really help us solve very important puzzles about the human brain, for example, or we will just be at loss, and because it's a complex system, and for that you need a much more abstract way of simplifying the system that you deal with. And it's so a theory of everything is not really the Holy Grail. The Holy Grail is explaining everything. Okay, so that means explaining the human brain, how it works. And we are unable to explain the human brain, so we say, oh, we have free will. And free will is basically an admission that we don't understand the human brain, because what free will means is you have a very complex system made of neurons. That's what the human brain is. And it's very complex, and it responds to the environment, which is also very complex. And that's why we can't forecast what it will do. Mm-hmm. So we say there is free will, but the free will is simply the complexity of the system and the environment in which it operates that make it unpredictable. And so, okay, you can call it the system as if it has an ingredient called free will, but it's just the fact that it's so complex and unpredictable. Now, of course, as we understand more and more complex systems with neurons, like, for example, artificial intelligence is an imitation of the human brain in some way, a very complex system with neurons. It will also exhibit, my prediction is when you develop large enough AI systems that have a lot of connections, it will eventually exhibit free will in the same way that we see it in the context of humans. But the theory of everything, if Eric Weinstein writes a set of equations, that would not explain the human brain. That doesn't help us much. You really need to understand how systems that are complex operate. And that's a completely different level of architecture. It's a different level of, it's just like statistical physics didn't really solve the equations of motion of every atom and figure out how a fluid behaves. Instead, it realized that you can average over atoms and do some statistical measurements that would give you a sense of how the fluid of many atoms will behave. So in the same way, complex systems require a different treatment. You're not dealing with each atom. I don't care if you have a theory of everything that explains how each atom moves, because you can't really put it on a computer and calculate like 10 to the power 24 atoms moving together. Like, that's too much complexity. So there will never be a theory of everything, because there will always be complex systems that we cannot explain.
Oh, wow. Did you voice your comments about the geometric unity theory of everything, Eric Weinstein's opinion to him? Did he
Uh,
know your opinion is
well,
there's not much use of it?
we had a lot of conversations, and I did not get to discuss the issue of theory of everything with him. But if he will listen to this podcast, I will be glad to say exactly the same. By the way, what you see is what you get. When I speak about things, I always say
Yeah,
the
you're
same.
you're being
And
straightforward.
I'm
Yeah,
not, yeah. But
Yes,
I will be
very
glad
straightforward.
to hear his opinion in response to my
yeah.
comments. Yeah.
Well, I also want to ask while we have you, and Dr. You can close us out with any final questions, but one more for me is you were talking about the brain and how, trying to get inside the human mind. And I have to wonder that question when it comes to Congress and this topic of UAPs, right? I mean, Congress in general, yeah, but in particular, given this subject, their statements they're making about these unidentified aerial phenomena, they keep talking about them being in the ocean. That Tim Burkett and others,
Right,
Anna Paulina Luna, they've been on my show. These folks, folks who are in the Navy,
right.
have been on our show talking about eyewitness tic tacs going in the water, coming back out, flying. Just beyond our comprehension. Uh, you talk about charting the interstellar world. What about let's just figure out what's in the ocean first? And
Oh, yeah.
what do you think about that? Yeah.
By the way, I very much resonate with the efforts that Representatives Anna Paulina Luna and Tim Burchett are doing, and I'm in contact with them continuously. And I salute them for the effort to disclose more information that the government may have on such things, because there are a lot of things we don't understand. It would be nice if scientists can get engaged and help the government figure it out. The government's duty is national security. Okay, it's not the fundamental science within government. They need the help of scientists to figure out things that go beyond national security. So I just think it would be helpful if they were to open up, for example, puzzles data that was collected, let's say 50 years ago. Okay, that kind of data cannot really risk national security today because any technologies that other nations had 50 years ago are not relevant today. So we should know what the government knows about unusual phenomena 50 years ago, let's say, or you can decide about the time frame. It could be even 25, because technology is evolving so fast that whatever existed 25 years ago is irrelevant today as far as humans are concerned. But I very much salute their efforts, and I hope that that there will be some information that will be disclosed. But at the same time, I'm not waiting for the government to release the information. I'm leading the Galileo project that is engaged in searching if there's anything unusual, in the atmosphere, or I would also obviously be interested in the oceans as well. Yeah. So I hope that these efforts will bear some fruit if there is something unusual. Yeah.
Very good. Well, watch the oceans. Watch where you put your fishing line. You don't know what's going to come up next. But Doctor, any final questions or thoughts as we wrap?
Oh, sure. Yeah. I just want to, can you show the screen? And I show the professor. Yeah. I want to make sure, my view on theory of everything, I do believe there is a theory of everything, not just mathematical theory of everything. It's has a physics explaining power for all the observed natural phenomena.
Right.
So just like I believe we had a tax exchange, right? If we are somehow where you're going to interview me sometimes later on, and I wanted to convince you there are theories of everything and can explain any unknowns, natural phenomena.
Yeah. No,
Any
I
question you have?
agree that it's in principle a valid point, but that's why I want to meet an alien scientist, an extraterrestrial scientist that knows much more than we do, because it will save us time instead of
Yeah.
us figuring out the answers. Maybe they know them already.
Yeah. But to be continued. Maybe that we'll leave it there as a cliffhanger. Next time you guys get together, we can get into the theory of everything stuff. How about that?
Okay, that'd be wonderful. Yeah.
All right, very good. And best of luck with your book, Interstellar. Everybody should take a look at it. Okay. Yeah, let's see. There it is. Interstellar,
wow.
Avi Loeb. Check it out. Thank you for your time, sir.
Thanks for having me.
And also
Thank you.
thank you, Dr. Yu, for joining us. This was a fun conversation, wide ranging, and really enjoyed it.
This is the second time around.
Yeah.
We always had a good time, right?
Yes, thank you. Any dialogue is two-way, and so I'm really grateful for your comments and questions. Thank you.
Thank you. And if you want to be in touch with us, folks, you can always email us hello@aneighborschoice.com, or like the video you're watching, or drop a comment. Stay in touch with our community. I'm David Gornoski. Godspeed.
Another